Welcome to the Rich Report, a podcast with news and information on the world of big data. Today my guest is from EnterpriseDB. We have Tegan Padir. She's Executive VP of Products and Engineering at the company. So Karen, welcome to the show today.
Hello, thank you. Happy to be here.
You bet. It's our pleasure. We're glad to have you on the show. I've brought your slides up. I'm kind of interested in the top benefits of cloud databases. So can you tell us more about that?
Sure. So we'll start with just a little introduction and background on me and the company. So we'll start on slide 2. I'm responsible for all things product at EnterpriseDB. That includes kind of our product management, design, to engineering support services and training. And we are all about Postgres, which is the community open source relational database. We've been founded in 2004. We are a small but very nimble and strong team across many geographies. And what we do is we build productized Postgres. We help the community. We engage in community activities. We fix bugs for the community. We do one-click installers for the community, and we do feature enhancements, and we do all of that in the community. Additionally, we provide support services and training, and we have some proprietary value-added features around Postgres that we sell. And we are a venture-backed startup, and we're backed by both venture capitalists you see there on the bottom and also some strategic vendor investors like IBM and Red Hat and NTT and Korea Telecom. So what we're going to talk about today is about cloud and cloud databases. And so if we move to slide 3, I think it was important to really look at, there are so many options around the cloud. It's quite cloudy and getting a little crowded. And I think we have to first look at, okay, when you're moving to the cloud, which cloud platform are you targeting, and are you really going to the cloud at all? And so here on this slide, I just kind of have a list of things, and this is how we look at it and think about it at EnterpriseDB. There's the cloud underlying infrastructure and platform, whether you're writing your application on top of Amazon, where you're going to use all the feature set of Amazon Web Services, or you're writing to an open source solution or an open source platform like OpenStack or CloudStack, where you have a variety of vendors contributing to build that infrastructure for that cloud environment. And then when you're on the cloud, you are choosing, not only the platform to have your application on, but also those runtime services that are available on the cloud. And so you really, when you say cloud, it means something very different to many different people. And then the other thing is that you hear this a lot about private cloud, and private cloud is really a step farther on top of just basic data center virtualization. And we're finding in our business that people are on all different aspects and spectrums here. They're, totally on the public cloud, depending on someone like Amazon or HP or Rackspace. They're also running on a private cloud where they have something like Eucalyptus, which is their cloud infrastructure, or vCloud from VMware. But we also find a number of vendors that really just have idle compute power in their data center, and they want to be able to tap into that. And so they run in virtualized environments with just VMware virtualization or other things, and they want to turn that into a cloud offering for them, but they're not ready to go adopt yet another piece of technology and bring that into their data center. So when we're looking at this whole landscape, we want to say, okay, well, what does this have to do with the database? And so if you flip to slide 4, we're going to talk a little bit about what a cloud database is. So, people would say, Karen, come on, a cloud database is just a database that runs in the cloud. That is true. You can have just your traditional data center databases, like the ones listed here, Oracle, MySQL, DB2, et cetera. You can take, pretty much almost any piece of software that you have, you can take it from your on-premise, from your laptop or your server or in your data center, and just move it to a public cloud computing environment, because that is the promise of the cloud, is that you have machine instances available and they're running an operating system, and they have the different underlying, compute and storage that you need to run your application. And so one way to look at it is you can just take your database and move it to the cloud. And then, but there are other things that we have to do to really have the database take advantage of the full feature set that's available in a cloud offering. There are many different databases going on in the cloud, and you see that there were even analytical databases that moved to the cloud, kind of in the late 2000s, like Netezza and Vertica and Greenplum and others that you see listed here. Some of them were, early adopters doing some development and testing, but their basic issue was they couldn't take the licensing became a problem when you move these traditional data center things and move them into a cloud. And what happened is you see the kind of onset for two reasons of these new NoSQL databases. They are, most of them, or pretty much all of these are open source. They're developed in communities, and they but they're designed to meet a different premise, right? So you're designing it to meet availability, and you are willing to make a trade-off for data consistency, and you want it to be used for, primarily it was used for new development projects, and it was all about the scalability requirements of distributed architectures. And you didn't really, you wanted to have schemaless data management. Everyone was saying, okay, we're going to be the next Facebook, we're going to be the next Google, we're going to be the next MySpace, the next, large communities of users, Twitter, where you're going to be collecting so much data, and it's more important that you can collect the data and store the data than it is to have it all be exactly up to date, exactly at that moment of time, which is a complete opposite approach to the traditional data center databases and the traditional SQL databases. So if we move to slide 5, I'm going to switch now, and I was talking a lot about, the different types of databases that are in the cloud. But I think the one sweet spot of the market that still is evolving and needs to be addressed is the relational database in the cloud. And why? Why? Because people are moving to the cloud, and they have their applications, and they use the universal tool sets that are available for SQL databases. So you have an application that writes SQL, and you want to be able to continue to use that application. You want to be able to leverage the skills that you have within your environment and the skills that you have, that the folks have that are writing your applications or administrating your databases. So, and you want to have an ACID compliant database, because most people are writing transactions, and the consistency of the data is actually more important. But to do that, you want to still be able to scale transparently. You want to be able to, within the cloud, you have this notion of infinite resources, right? If you need more disk space, bam, it should just appear. If you need more compute power, again, it should just appear. It's in the cloud. It's infinite, and you want to have the ability to grow with that. Well, in the database world, especially in the relational database world, that wasn't exactly true. It's hard to do. It's hard to tell a database that suddenly you have a lot more storage that you can use to store your data in, and it's difficult to have it, scale both vertically and horizontally. And so having the ability to scale transparently really provides the user and that developer of that application the ability to take advantage of what the cloud truly promises. The other thing that we're noticing as people are flipping and moving into the cloud is that the database administrator is becoming closer and closer to the point of the development. So I've talked to a number of customers that we have on our cloud database, and many of them, they're not database administrators. They don't want to be. They're the developers. Their core purpose is to develop their application and service their application for their customer needs. And data is a part of that. The database is certainly a part of that, but that's not where they're adding their value add. They're not a database company. They're an application vendor that's doing an application as a service or an online web application. And so they want to focus on their business value add and not worry about the database. And so they don't have sophisticated database administration skills, and they don't want to. And so having the ability to have, your database just automatically heal itself. If a node fails, you can recover that node. If your master fails, you can fail over to a replica or start a new master. You want all of that to just happen automatically. Automated backups with as your data grows and you're getting into this, big data, backing up your data is a problem. And how do you do that? And so making sure that there's an automated way of doing that is important. And similarly, database cloning, because we're finding that customers are looking to set up and provision new databases and new applications with the database embedded in it for their users. And so they don't want to have to go, provision everything from scratch, but this nice point-and-click provisioning of a new database with all of the data that was already in it for a new use or a new application is important, and people are looking for that as well. Item number 4 here, as we talk about universally pluggable and portable, I think people think cloud and they think, okay, it's in the cloud. If I'm on one cloud, what's the difference between one cloud and another cloud? And you find as you dig in, there's a lot of differences. And you really have to be careful to determine which cloud you're going to and where you're making a choice to get locked into a particular cloud vendor. And then I have another list of here of things that are also important in the cloud. Certainly monitor management and administration across the board, whether you're talking about the database or your application environment, you need to be able to centrally manage and monitor everything that's happening. Things have to be really super simple. We live in this world of instant gratification, and if you can't get something up and running in 5 minutes, people tend to give up, or they'll go look for something else that is more simple and easy to use. The other thing is around pricing. This utility computing model, it's easy for me to just, hey, I need a big honking server for a couple of hours. I'm going to go use it, and I'm not going to worry about having to procure it or set it up, make sure it has all of the operating system I need and all of the components I need. You can just go to the public cloud and do that. And then one of the other things about the cloud databases is we're increasingly seeing the need to interact between different types of data stores, whether it be between a relational database and a NoSQL database, or even within the data warehouse vendors being able to interact with your more OLTP database. We're seeing lots of this need to interact between these different data stores and databases. So as I move to slide 6, this is probably pretty obvious, but as you go to the cloud and you see all these very different cloud development environment, whether it be Microsoft Windows Azure on the top, to Red Hat OpenShift on the bottom, to Amazon. I have a picture that CloudBee has put together over there, and Engine Yard. The database is part of the developer platform because the developer is still storing their data. And you'll see with all of these platforms, you're seeing the ability to generate code and then to store data in various environments. So you can store data in your relational database. You have different options. Even Amazon offers a relational database service, which is Oracle or MySQL, and they also have their own new one, which is the NoSQL-style database of DynamoDB. So there are lots of choices and lots of options out there for your database needs in the cloud. Now, moving on to slide 7, we have to be careful. So this is one thing that I think people need to pay attention to when you move to the cloud, is that most of the cloud databases are on a particular cloud platform. So if you look at the different database that you have here, you have Oracle and you have IBM DB2 and SQL Server, Sybase, MySQL, even Postgres and our Postgres Plus advanced server products. All of those are traditional databases, and you move them to the cloud, and you see that the cloud provider has pretty much locked into a particular database. And even if you say, okay, well, no, Karen, that's not quite right, because you look at the different cloud platforms and most of them have a MySQL offering. And that's true, but it's not a standard off-your-shelf MySQL offering. And so you're going to have portability problems. So I was reading an article recently, and certainly it has been brought up to me by some of our customers, about how it takes a lot of time, just the performance and the compute power, to move from one cloud platform to another. And this is just a simple file transfer. So say you've stored some files on Amazon and you want to move over to Microsoft's Azure platform. The data transfer rates, depending upon, in and out, and which direction you're going from the cloud, vary significantly. And that is just for a simple, text file or a simple file transfer, and the file format. That gets much more complicated when you talk about database and data format. So one of the things that people should look out for is, as I'm choosing this cloud database, am I choosing it because it's easy and it suits my needs, but will I be locked into this in the end? Am I stuck on Amazon? Am I stuck on Microsoft because I've done all this development and I'm deploying my application there, and now I have no way to really get my data out of there without a big migration task? And so one of the things that we're trying to do, this is my little commercial about Postgres Plus Cloud Database, is we're looking to put community Postgres, untouched, open source community Postgres on all the major cloud platforms, such that you don't have to worry about this lock-in. You can start with Amazon, you can start with HP's cloud, you can start with any of the cloud stack implementations or Rackspace, and you can have comfort in knowing that it is the off-the-shelf community Postgres that's just been optimized to run well in the cloud environment, but the data structure and the data format and all the tools that you would use to back up your database or offload your database or load data in your database are exactly the same whether you're in the cloud or if you're on-premise in a data center. So moving on to slide 8, PostgreSQL is an open source database. If you guys are not familiar with it, it's fully ACID compliant. It has multi-version concurrency control. We have point-in-time recovery and a whole list of other nice features. The history of Postgres is it's been over 25 years of development, and Postgres actually stands for Post-Ingres, that was created out of the University of Berkeley. And so the Postgres community started about 25 years plus ago, and it's a very vibrant open source community that has 6 core members that govern and manage the community and many committers, and they have a very open process. There are lots of mailing lists. There are many ways that you can contribute, and the license that is associated with Postgres is the Postgres community license. It is a BSD style license, so we're not trying to get people to lock in. If you make any change, you have to give it back to the community. Of course, as a community member, we appreciate contributions, and we have a very vibrant and community that allows contributions and very active. We issue a new release every year. Currently, we're in the PostgreSQL 9.2. We're going to have a beta release coming up shortly, and then we'll probably release that generally available in the fall. So I encourage everybody to go check out PostgreSQL.org to learn more about Postgres. And so moving on to the next slide, what we're doing at EnterpriseDB is we're creating Postgres Plus in the cloud. And this is a picture that just kind of has a nice image, and you have the ability. Right now, we're available on both Amazon Web Services, but also on HP Compute Cloud that was just announced on the 10th of May. So you can choose which platform you want to run on. Within each platform, you get to choose. Do you want to run our Postgres, community Postgres off the shelf, as I said, unchanged? It's only optimized for running in the particular environment, or do you want to use Postgres plus Advanced Server, which is EnterpriseDB's product that provides additional security, performance enhancements, and Oracle database compatibility. On slide 10, I'm just going to tell you a little bit about the features that we provide in our Postgres plus Cloud database. As I mentioned, you can choose if you want community Postgres or Postgres plus Advanced Server. And way back, I think on my first or second slide, I talked about the different cloud environments. We're building the product so that it can run in all of the environments. We want it to be available on all public clouds. And then as there is private clouds, on a strong platform where there's lots of adoption, we will absolutely provide a private cloud implementation of our Postgres Cloud database. And additionally, as I talked about virtualization in your standard data center, we believe that some of the features of this product are very compelling for people, whether they're in or out of a cloud environment. It's difficult to set up a database cluster that has a master and various replicas that can automatically fail over, that can automatically self-heal itself, that can start new servers when it needs to, that can add new nodes if it needs to. And so that is relevant whether you're in your public cloud or whether you're in your private cloud or just in your bare metal, your standard data center deployment. We have a very nice point-and-click simple setup and management. It takes literally 2 minutes to start up a database cluster, and you can choose how many nodes you want within that cluster. You can have a master and 3 slaves, 5 slaves, as many slaves really as you want. We have transparent node additions, so if you're an auto scalability. So what happens is if your database is running and you're running out of connections, or there are lots of database connections and a lot of usage of your database, we will automatically start up a replica. And with load balancing built in, the write queries will stay on the master and the read queries will get offloaded to some of the read replicas. So that happens automatically. Additionally, we automatically add disks for you if you're running in the public clouds and you're running out of your disk space. You don't have to worry about predictive analysis of when I'm going to run out of disk and therefore I need to intervene and do something. It will automatically add disk storage for you, so you don't have to worry about that. I mentioned our Postgres plus Advanced Server product, and one of the big advantages of that product is it has Oracle database compatibility, so you can take your application that was written to store data in an Oracle database and migrate that very easily into our Postgres plus Advanced Server product. And again, that's one of the database engines that's available in our cloud database. And, it's much less expensive. And so one of the value propositions of the cloud is really around saving money, and also open source about saving money. So we want to, make sure it's accessible for a lot more people to use the project and get off of Oracle. We have built-in load balancing, which I just mentioned about the connections and the connection pooling and balancing the load so that, not one of the database nodes is completely taxed while other databases are sitting there idle. We have online backup, point-in-time recovery, and the ability to clone database. As I mentioned before, we are currently available today on Amazon Web Services and the HP Compute Cloud. And we have implementations of the product on OpenStack, and also we're building out on CloudStack as well. Slide 11 just kind of summarizes everything up. So why do you move to the cloud, and what are the reasons that you would move to the cloud, and how does the database affect your choice in the cloud? The cloud is going to be very successful. We've seen it We've seen it grow and mature, even in the last 6 to 9 months. One of the key things is, there's CIOs are absolutely in love with the cloud, and I think it was either Gartner or Forrester recently did an article about the percentage of CIOs that are looking to migrate to the cloud, do some sort of development, and offload some of their applications to the cloud in the next year to 5 years. And I think it was, an astounding 90+% of CIOs are looking at it today. So that's huge. And I think when there's developer choices, when people that are doing the development are liking the cloud environments and using the cloud environments and developing on the cloud in these developer platforms, and you have support from the corner office, from the executives, you're going to see successful adoption of that technology. And so you have lots of scalability, you save time and money, and just have a much easier time to be using these products, whether they be your application or your database and alike. And watch out for portability, because there are portable options. As you can see, the growth of the OpenStack platform, where you have a number of major vendors supporting that as a cloud infrastructure platform, so that people can adopt that and then applications can move to the variety of cloud providers. You're going to see more portability. So just take a look at that and pay attention to that.
Well, great. Thanks for that, Karen. So a couple questions here. Back at Sun, when I worked there, we had the saying that you date your hardware vendor, but you're married to your data. And when you guys talk to clients, are they concerned that that maybe that data integrity might not be there? Like, what if I got married to Amazon and they decided one day they weren't going to be in this business or something, and all my data was stuck there? How could I move it to, say, the HP cloud? Is that the kind of thing you have to deal with or concern?
Yes, it is. It's a serious concern. And one of the reasons, quite frankly, why our design principles were around optimizing off-the-shelf community Postgres or our off-the-shelf Postgres plus Advanced Server product for these environments, for that very reason, right? People, fell in love with Linux and, barrier to entry makes it very easy to have a barrier to exit. That was another thing we said at Sun a lot too, right? And so, we saw it with Solaris going to Linux, and we saw it with kind of open source application servers going to, different products within Apache and, Portal and all the likes as you go up on the middleware stack. And so it's going to continue to happen here. And I think, all of us in the technology community, vendors and users alike, have gotten smarter over the years and have said, hey, you know what, I don't think, 15 years ago, portability was an issue when the procurement office was making a purchase in a company. Now it is. We just signed a very large customer, and one of the things they told us was, is we went with you guys because we knew that, we have alternatives if something happens to you. And we're like, yeah. And they thought we were going to get upset about that. And we're like, no, yes, that's our value proposition. We know that. But we know people will be successful and they will stay as long as they don't feel like they're locked in and required to stay with no other options.
Right. So I'm curious about the engagement process, Karen, in terms of support, right? So say I'm running EnterpriseDB, I'm running the database on Amazon, right? And for some reason it's slow, but I engaged with you, and Amazon's telling me that the servers are all happy. They don't know what's going on.
Mm-hmm.
I mean, how does that work?
Well, I think so. A couple of things. I mean, it depends on what people are doing. So there's a whole bunch of folks that are just doing dev and test in Amazon, and they're perfectly happy to do it yourself, right? Don't need to engage in any kind of service or support contract with any vendor. I'm just going to go pay for what I use, and I'm going to do it myself, and I'm going to be fine. Now, that said, there can be people who, like you said, are looking at it and say, hey, it looks like everything's running really well, but it's slower than it should be or slower than I thought it should be. And so what we do is a couple of things. One is we have a basic support contract where you can, engage in support with us, and we'll, answer your calls 24/7 and, help you troubleshoot. We also have professional services things that will go and do some architectural health checks on your database and your application environment, help you get performance increases from that. Additionally, we're finding a growth in our business around remote DBA services. And these are all things that apply to both the cloud and your traditional data center, where it's very hard to find good on-site database administrators. And so people are kind of outsourcing that to people that know the product well and, live and breathe databases all the time. So we have people who say, hey, I have my application, you're responsible for my data in my database, and I don't even want to worry about it. Just give me a port number. I'm going to connect my app to that port number, and that's it. I don't want to have to worry about it. And we're seeing a very big increase of people who want to engage with the database at that level.
So Karen, I'm just trying to think, how would somebody size this market given the explosion of data? I mean, have you looked at what the potential upside is for EnterpriseDB as we see this growth?
Yeah, it's a great question. Forrester just recently did the Sizing the Cloud. They had a research article about that, and it had some, enormous numbers. And I don't have it in front of me, but it's, many billions of dollars over the next 5 years or so. So we're seeing a lot of people grow with it. For us, we're looking at it right now as an opportunity to attract new customers and to provide folks that typically, wouldn't have known about us, wouldn't have heard of us, might have thought about using Postgres, but mostly MySQL shops. We're finding people are getting more savvy, and there's a lot of folks that are kind of wandering away from MySQL. The big reason is they're just afraid of Oracle. They don't want to be locked into another contract with Oracle. And, so they're looking for alternatives. So for us, it's certainly a revenue opportunity for us. Right now, we're just using it to kind of expand our reach.
Sure. So kind of a wrap-up question here, Karen. How does is someone able to kick the tires on what you guys provide and test it and see if it's right for them?
Yeah, absolutely. So if you go to our website, enterprisedb.com, and there's a big cloud button, Cloud Database, you can click on that, and there's an option to do a free trial, and you can just self-register yourself and go right in and use the product.
Well, terrific. Well, Karen, I want to thank you once again for coming on the show today.
You're very welcome. Thank you, Rich.
You bet. Okay, folks, that's it for the Rich Report. Stay tuned for more news and information on the world of big data.